So here is another question. It is given to what potential, electric potential, we must charge an insulated sphere of radius 14 centimeter so that the surface charge density is equal to 1 microcoulomb per meter square. Okay. So here we have a sphere, insulated sphere of radius 14 centimeter. Okay, that is the radius of the sphere. Okay, so the area of the sphere, the surface area of the sphere, that is equal to 4 pi r square, and we know that the surface charge density, that is equal to the total charge divided by area. Okay, this. So here it has been asked to find out the potential of this sphere so that the surface charge density is equal to 1 microcoulomb per meter square. So we know that the electric potential due to a charge, that is equal to 1 by 4 pi epsilon 0 q by r. So here r will be the radius of the sphere. Okay, r will be equal to 14 centimeter. The charge q will be equal to sigma multiplied with the surface charge density multiplied with the area, that is equal to 4 pi r square sigma. So this will become 1 by 4 pi epsilon 0 4 pi r square sigma by r. So that will be equal to 4 pi r sigma by 4 pi epsilon 0. Okay, so sigma is already given, which is equal to 10 to the power minus 6 coulomb per meter square. This will convert it into meters, 14 into 10 to the power minus 2 meters. So this will become, okay, here this will become, if we put the values here, don't cancel 4 pi, just use the respective values. 1 by 4 pi epsilon 0 will become 9 into 10 to the power 9, then 4 into 3.14 into 14 into 10 to the power minus 2 into the surface charge density 10 to the power minus 6. So this becomes how much? It's coming, rounding it off, 15840 volt. Okay, 15840 volt, 15,840 volts. So this should be the potential of the sphere so that the surface charge density, that is equal to 1 microcoulomb per meter square. Okay, so here is another question on electric potential. So it is given to calculate the electric potential at the center of a square of side √2 meter having charges 100 microcoulomb, minus 50 microcoulomb, 20 microcoulomb and minus 60 microcoulomb at the four corners of the square. Okay, so here it is given that we have a square of side √2 meter. Let us say it has the four corners A, B, C, D, and we have the center O. Okay, so let's say we have the 100 microcoulomb charge situated here, the minus 50 microcoulomb charge situated here at B, plus 20 microcoulomb charge at C, and minus 60 microcoulomb charge at D. So we have to find the electric potential at the center. So for this, the distance AO, BO, CO and DO, which are all equal, we have to calculate that. So which is half of the diagonal, okay, the diagonal distance AC or BD. So AC and BD, that is equal to the diagonal which is equal to root 2 square plus root 2 square, which is equal to 2 plus 2, that is equal to 4 root over of 4, that is equal to 2 meters. So half of AC and BD, this is equal to 1 meter. Okay, AO, BO, CO and DO. So now we know that the electric potential, the working formula here is that electric potential due to multiple charges which are located at different distances from a certain point where we have to calculate the electric potential, that is given by 1 by 4 pi epsilon 0 which is common, then Q1 by R1 plus Q2 by R2 plus Q3 by R3, and this goes on for as many charges which are present. Okay, nth charge and the distance of that nth charge from a particular point where we have to determine the electric potential. So here Q1, Q2, Q3, they are these values, these charges: 100 microcoulomb, minus 50 microcoulomb, 20 microcoulomb, minus 60 microcoulomb. All of these distances R1, R2, R3 and R4, 4 charges, they are situated at equal distances from the point where electric potential has to be calculated. So this will become the net potential at point O, that is equal to 1 by 4 pi epsilon 0 QA, which is equal to 100 microcoulomb, by RA, that is OA, which is equal to 1 meter, minus 50 microcoulomb by again 1, that is equal to OB. Okay, then plus 20 microcoulomb by CO, that is equal to again 1, then minus 60 microcoulomb by again OD, which is equal to 1, or are equal to 1. So that is equal to, it is coming 9 into 10 to the power 9, 100 minus 50, that is 50 plus 20, 70 minus 60, that is equal to 10 microcoulomb. So 10 into 10 to the power minus 6, so 10 to the power minus 5, that is equal to 9 into 10 to the power 4 volt. That is the net electric potential at the center O due to these 4 charges QA, QB, QC, QD, which are situated at the 4 vertices, the 4 corners of the square. Okay, yes.